Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this channel we cover all things Gen Chem related. On this video, we're going to be learning about Avogadro's law and how to do calculations associated with it. Let's get started. In previous videos, we learned about other simple gas laws like Boyle's law, which is looking at the relationship between pressure and volume. We also learned about Charles' law, which is looking at the relationship between volume and temperature. Well, now we're going to be focusing on Avogadro's law. And Avogadro's law is looking at the relationship between the volume of a gas and the number of particles that are present, or the number of moles. Now, what we're going to learn here is that these two variables have a direct relationship. So as I change one, the other goes up, or if I decrease one, the other one goes down. So there is a very similar relationship to what we saw in Charles' law. And so when we're looking at this relationship, we're assuming that the other variables like pressure and temperature are being held constant. And so when we're counting these things, we're counting the number of gas molecules by counting the number of moles that are present. And remember, when we're doing this, it doesn't matter what gas we're dealing with, the counting process will be the same. Much like we saw with the Charles law, there is a linear relationship that exists between these two variables. So take home message, the more molecules that are present in something, the greater the volume will be. And the lower number of molecules that are present, the smaller the volume will be. A great way to remember this, again, I love a good mnemonic device. If you look at Avogadro, at real quick glance, it kind of looks like the word avocado. So avocados are very nutritious. So very would represent the volume. Nutritious would represent N, the number of moles. Okay, so use that if you like. I love a great mnemonic device. They've always helped me out. And so when we're plugging this in, we're going to be plugging in just like we've done before. So this problem says if 1.0 mole of gas occupies 22.4 liters at STP, what volume would 0.75 moles occupy? Okay, and so let's look at our variables. It says, well, we have if 1 mole, so that would equal N1, occupies a volume at 22.4 liters at STP. And we'll talk about STP in 1 second. We now want to know what volume, so that means V2, would 0.75 moles occupy. So that would represent our N2. Just as a quick side note, STP, anytime you see that, and we'll talk about this in later videos, STP just simply means standard temperature and pressure. And so standard temperature and pressure are 273 Kelvin and 1 atmosphere, okay? But for this particular problem, we're not going to worry about it because we're assuming that they're held constant, okay, in an Avogadro's law type of problem. And so what we would look at is using the equation of V1 over N1 is equal to V2 over N2, and we're solving for V2. We rearrange, V2 would equal V1 times N2 divided by N1. And the great thing about these problems, they're ready to just plug and chug. So we can now put our V1 of 22.4 liters times N2, which is 0.750 moles. And we're going to divide by N1, which is 1.0 moles. Okay. So we have 22.4 times 0.75 divided by 1, and we end up with 16.8 liters. Okay, and again, that makes sense that we saw this decrease because our volume, our number of moles decreased as well. I hope this video helped you understand how to quickly do Avogadro's law problems. Make sure you guys like, comment, and subscribe, and let me know what other content you want to see. I'll see you guys in later videos. Check with you later. Bye-bye.